Hubble's family moved to Wheaton, Illinois when he was 9 years old. This move would prove significant in shaping his future. The new environment offered more opportunities for young Edwin to explore his interests. He excelled in both academics and athletics at school. His teachers noticed his sharp mind and encouraged his scientific pursuits. Young Edwin Hubble. As a teenager, I was torn between my love for science and my father's wish for me to pursue law. Despite my passion for astronomy, I initially chose to honor my father's wishes. Edwin Hubble's educational journey was as expansive as the universe he would later study. He began his higher education at the University of Chicago in 1906. Here, Hubble's intellect truly began to shine. He studied mathematics and astronomy under some of the finest minds of the time. His professors recognized his exceptional abilities and nurtured his growing interest in the cosmos. Young Edwin Hubble. Despite my passion for astronomy, my path took an unexpected turn after my undergraduate studies. Honoring my late father's wishes, I accepted a Rhodes Scholarship to study law at Oxford University. This detour into the legal world lasted from 1910 to 1913. During this time, my mind remained active, absorbing knowledge from various fields. Upon returning to the United States, Hubble briefly practiced law in Kentucky. However, the call of the stars proved too strong to ignore. In 1914, he made a pivotal decision that would change the course of his life and the field of astronomy. He returned to the University of Chicago to pursue a PhD in astronomy. Young Edwin Hubble, my doctoral studies focused on nebulae, then a mysterious and poorly understood phenomenon. My dissertation, completed in 1917, laid the groundwork for my future discoveries. In the early 20th century, a fierce debate raged in the astronomical community. The question at hand was fundamental. What were the nebulae observed in the night sky? Colleague Edwin Hubble stepped into this debate, armed with the most powerful tool available to astronomers at the time, the 100-inch Hooker telescope at Mount Wilson Observatory. This massive instrument allowed Hubble to peer deeper into space than anyone had before. On October 6, 1923, Hubble made a discovery that would change astronomy forever. He identified a Cepheid variable star in the Andromeda Nebula. Colleague Hubble's calculations revealed that the Andromeda Nebula was far too distant to be part of our own galaxy. This conclusively proved that Andromeda was, in fact, a separate galaxy, an island universe of its own. With this single observation, Hubble had expanded the known universe by an unimaginable degree. Building on his groundbreaking discovery of other galaxies, Edwin Hubble embarked on a new quest. He began systematically studying these distant cosmic islands. Hubble meticulously measured their distances and velocities. This painstaking work would lead to perhaps his most famous discovery, the expanding universe. Colleague Hubble collaborated with Milton Humason, a fellow astronomer at Mount Wilson Observatory. Together, they observed dozens of galaxies. They used the Doppler effect to measure the galaxies' velocities. As they collected data, a startling pattern emerged. Almost all the galaxies they observed were moving away from Earth. Even more surprisingly, the farther a galaxy was, the faster it seemed to be receding. Historians draw, Hubble's observations pointed to a revolutionary conclusion. The universe itself was expanding. Hubble's meticulous data was hard to argue with. This discovery would form the foundation of modern cosmology and our understanding of the Big Bang. Section 5, Hubble's Law, a cosmic speed limit. The relationship between a galaxy's distance and its velocity away from us is now known as Hubble's Law.
This simple yet profound principle states that the farther away a galaxy is, the faster it appears to be moving away from us.
It's often expressed mathematically as v equals h-tau times d, where v is the galaxy's velocity, d is its distance, and h0 is the Hubble constant.
The Hubble constant, h0, is a measure of the current expansion rate of the universe. Determining its precise value has been a major goal of astronomers for decades.
Hubble's initial estimate was much higher than modern values. due to limitations in measuring techniques of his time.
Hubble's law has far-reaching implications for our understanding of the cosmos.
This idea forms the basis of the Big Bang theory, the prevailing model for the origin of the universe. The law also allows astronomers to estimate the age of the universe by calculating how long it would take for galaxies to reach their current positions.
Section 6. Redefining our place in the cosmos. Edwin Hubble's discoveries fundamentally altered our perception of our place in the universe.
Before Hubble, the prevailing view was that our Milky Way galaxy constituted the entire universe. We thought we were at the center of everything.
Hubble's work shattered this notion, revealing a cosmos of unimaginable scale. The realization that we inhabit just one of countless galaxies was profoundly humbling.
It forced a re-evaluation of our cosmic significance. No longer were we at the center of creation. Instead, we found ourselves on a small planet, orbiting an average star in one of billions of galaxies.
This shift in perspective was as revolutionary as Copernicus's heliocentric model had been centuries earlier.
Hubble's discovery of the expanding universe added another layer to this new cosmic view. Not only was the universe vastly larger than we had imagined, but it was also dynamic and evolving. Section 7. The Hubble Sequence, Classifying Galaxies. Edwin Hubble's contributions to astronomy weren't limited to discovering the expanding universe. He also developed a system for classifying galaxies that is still used today.
This system, known as the Hubble Sequence or the Hubble tuning fork, organizes galaxies based on their visual appearance. The Hubble Sequence divides galaxies into three main types: elliptical, spiral, and irregular.
Elliptical galaxies are smooth and featureless, ranging from nearly circular to highly elongated shapes. Spiral galaxies, like our own Milky Way, have a central bulge surrounded by spiral arms. Irregular galaxies have no definite shape or structure.
Hubble originally believed this sequence represented an evolutionary path for galaxies. While we now know this isn't the case, the classification system remains invaluable.
Section 8. Beyond the telescope, Hubble's other contributions. While Edwin Hubble is best known for his groundbreaking astronomical discoveries, his influence extended far beyond the observatory.
He was a skilled communicator who understood the importance of sharing scientific knowledge with the public. Hubble wrote several books aimed at general audiences, including The Realm of the Nebulae and The Observational Approach to Cosmology.
Hubble's ability to explain complex concepts in accessible terms made him a popular figure. He gave numerous public lectures and radio talks.
This played a crucial role in garnering support for astronomical research and funding for new telescopes. In addition to his scientific work, Hubble made significant contributions during World War II. He put his analytical skills to use at the Aberdeen Proving Ground, working on ballistics.
After the war, he was involved in early rocketry experiments. Hubble was also a strong advocate for the construction of larger, more powerful telescopes.
Section 9. The Legacy of Edwin Hubble. Edwin Hubble's impact on astronomy and our understanding of the universe is immeasurable. His discoveries fundamentally changed our cosmic perspective. They opened up new fields of study and inspired generations of scientists.
The concept of an expanding universe in particular continues to be a cornerstone of modern cosmology. Perhaps the most visible symbol of Hubble's legacy is the Hubble Space Telescope. Launched in 1990, this orbiting observatory has revolutionized our view of the cosmos.
It has peered deeper into space than any previous instrument, capturing breathtaking images of distant galaxies, nebulae, and other celestial phenomena.
Hubble's work laid the foundation for many of the big questions in modern astronomy. The nature of dark matter and dark energy, the formation and evolution of galaxies, and the ultimate fate of the universe all trace their roots to Hubble's discoveries.
Section 10. Hubble's Impact on Modern Astronomy. The influence of Edwin Hubble's work on modern astronomy cannot be overstated. His discoveries continue to shape our understanding of the cosmos and drive new research.
The concept of an expanding universe, first observed by Hubble, has led to the development of the Big Bang theory. This model of cosmic evolution is now the cornerstone of modern cosmology.
Hubble's work also paved the way for the study of galaxy formation and evolution. By demonstrating the existence of other galaxies and developing a system to classify them, he laid the groundwork for entire fields of research.
Today, astronomers use advanced technologies like radio telescopes and space-based observatories to study galaxies across cosmic time. The quest to refine the Hubble constant continues to be a major focus of astronomical research.
Recent observations have led to conflicting measurements of the Hubble constant. This Hubble tension is one of the most intriguing puzzles in modern cosmology. It may point to new physics beyond our current understanding.